DHCP is a Dynamic Host Configuration Protocol. Basically, DHCP is just a dynamic way of handing out IP addresses. For our subnets, we are using two different Class B subnets, the 147.147.0.0 and the 165.15.0.0. However, we felt this was too many addresses that would be available. There's like 65,000 addresses per network available in there. We thought that'd be a pretty good waste of money to buy all those addresses, so we just chose to use a few because we only have a few machines that'll be using live IPs that actually connect to the internet. The rest of them are going to be within our private network using the private IP scheme. Private ranges. For our internal networks, Joe already talked about this a little bit. We got the 172.16 network for the USA side, and the 172.17.0.0 and the /20 with the subnet mask of the 240 for, well, subnet mask will be the same for both USA and Europe, but this .17 is going to be for the Europe side. Again, and a little more on the ranges here. The USA.NCIS, which is our first domain inside of our USA forest, the 172.16.01 all the way up to .15.254 that Joe just talked about just a little bit ago. And then you got your west and east, and you can see again where he was talking about it's just increasing 16, then going up another 16 to the 32. And of course, again, the Europe side is just going to mirror what the USA side did, making things nice and simple for us to do. Available IPs. You seen when he drew out how he got the amount of nodes turned on and off over here. We went from a little over 2,000, but we needed 2,200. The next bit that we turned on took us up to 4,096. But all that does is it just gives us plenty of room for growth down the road. IP type and assignment. We'll be using both static and dynamic addressing in our networks. The domain controllers, routers, and servers in each network will use the first 50 addresses. And will be statically added to the NICs of the machines. The rest of it will be handed out through the DHCP service. I'm going to talk about that just a little bit more, I think, down the line here with the print servers. But the reason why we're doing the statically assigned is like there's a lot of printers and print servers along in our network. And if something was to happen and they were either turned off or went down for more than the 8-day lease period, we wouldn't want to have to turn them back on and then have to go to every single machine in our area and reassign those IPs. When they come back on, boom, there's this exact same IP address. When you go to print to it, it's right there. You don't have to go find it. You don't have to have somebody come in and do a bunch of administrative work to get back to the same print. DHCP setup. To do this, you can either use administrative tools or add and remove Windows components. This is a member server, so we use the enterprise admin account because the enterprise admin account is the only account with the rights to go in and add this service. Configuring a scope. Our scope will include the entire 4,096 addresses using the default lease time of 8 days, which I was just talking about. The routers, the DNS, and the WINS addresses will be configured to use these scope options. Exclusions. We will exclude the first 50 addresses to be used for static assignment. This is what I was talking about a minute ago. The first 50 is going to be used for, like you said, the routers. We're already up to 12, so if we was to expand, it's not going to take long before we're going to start getting quite a few of those used up. Domain controllers, printers, just things like that. So we went ahead and excluded the first 50 to keep those separate from our networks. Plus the 20% of the entire range is to use for backup DHCP server to provide fault tolerance. What I'm talking about there is this DHCP server on the USA side is going to use 80% to hand out IPs for its users, and 20% in case the DHCP server on the Europe side goes down. They can then in turn still get an IP address from our DHCP server on the USA side. And they're going to do the exact same thing over there. Their server will be set up the same way. We're using the 80 to 80-20 split. They'll hand out 80% and keep 20% reserved for us in case our server was to go down. Then we set up a relay agent. Using routing remote access, we will set up a DHCP relay agent to allow our clients to contact DHCP servers in a different network. The relay agent will have the IP for the external DHCP server. The hop count threshold will be left at 4 and can be changed if needed to accommodate, if more routers do come into the system, we can easily go in and make that change. Plus the boot threshold, which is the wait time, will be changed to 6 in case for some reason our network's bogged down and run a little bit slow. The next thing I'm going to start on is DNS, which DNS is the Domain Name Service. DNS is, we're going to have it configured with Active Directory. Active Directory provides an enterprise-level tool for organizing, managing, and locating resources on a network, as well as secure dynamic updates for record aging and scavenging. We will replicate throughout the forest, creating a stub zone for Europe in order to share records and have the ability to dynamically update with that forest. The Europe side will also create a stub zone for USA so that it has the exact same ability as the USA side. The stub records that will be transferred will be the A, which is the host records, of the DNS servers in the domains, the SOA, which is the start of authority records, and the NS, which is the name server records. We chose the stub zone because it's dynamic. By that I mean, if something changes on one side, it automatically is going to change to the other side. Where a primary or second would require quite a bit more administrative work, and the goal is always to make it the least amount of administrative work that can be done. We did have the option of forwarders or conditional forwarders. However, we felt the use of Active Directory with a stub zone, again, would create less administrative work. Everybody likes the way that sounds. Define DNS plans. The root, the little dot right here, where the dot is actually the root of the name. There's actually a little dot down there, and that is the root. Top-level domains. Top-level domains are the rightmost portion of a domain name. It is usually stated with a 2 or 3 character name code that identifies either organizational or geographical status of the domain name. An example here would be one that everybody's real familiar with is .com, .net, .org, .gov, or .ca. Just name a few there. We've chosen to use USA.NCIS, and then a little note I put down here. It's only being used in a private network. The .NCIS is not going to go out onto the live internet. It's not able to go out there, so it's just an internal name that we chose to use there as our top level. And of course the NCIS stands for Network Creation and Implementation Specialist. Second level domain is a unique name of varying length that the interdict formally registers to the individual or organization that connects to the internet. So the second level would be USA.NCIS, where NCIS is the first level, top level, second level USA.NCIS, Europe.NCIS. And then we go into a subdomain. This is a way to further subdivide registered domain names by adding subdivisions or departments that are each represented by a separate name portion. And again, for an example, we got our top level, second level, and our subdomain. So it'd be west.usa.ncis and so on through east, west.europe, and east and west. Both east and west have become a child domain in our Active Directory structure, which have become subdomains for our DNS. FQDN stands for Fully Qualified Domain Name. The DNS namespace and the host name make up the fully qualified domain name. And for example, I put DC1 or domain controller 1.east.usa.ncis. That is an actual fully qualified domain name. Figure in the DNS servers. Our servers in each domain will be configured to use root hints. Root hints are stored in the file cache.dns %system root %/system32/DNS folder. To check for information that it does not have in its own records or its own cache. An example is there's a query for google.com. It will contact the .com. If for some reason you've never been to Google, it doesn't have it in its cache, it will go out to the .com root and look for that information.